Hi, my name is Evan Schwartz, and we're going to be looking at Week 1 and Week 2 development project for game development frameworks. And we're going to start with the iPhone. And the game that I built is called RollaMole, and that's the icon for it there. We'll go ahead and get it opened up. And the splash page, they'll show that I built it in Unity. How to play. Gives you some instructions. Essentially, you're going to be controlling through the accelerometer of the device the tilting motion of the playing field that's going to roll a ball around trying to squish worms. In addition to that, you can touch the worms and hold them in place because the worms will wiggle up, stay there for 3 seconds and wiggle back down. If you just touch and hold, you can hold them there. If you touch, press to push, you can squish them. The worms can bite you. If they bite, they're red, their faces turn red, and you can't squish them anymore. You have to roll over them. And then we support a 2-finger touch if you've got a roller, and it will cause the roller to appear, and then you can tilt and have the roller squish the whole playing field. Worms are 1 point, and biting worms are 5 points. You can't squish a worm that's already bitten you. On the credits, developed by me, Evan Schwartz. All the music is weststarmusicsourceaudio.com, and 2 packages I'm using is a Skybox package just for the background, and nice vibrations from Warm Mountains just to get the haptic feedback. We're going to most likely end up having to redo what he did in the capstone. Not super happy with his implementation. Alright, let's get into the game.
Are you ready to
Come over here a little bit so you can see. So as it starts, level 1, and you can see that tilting the device has caused the platform to spin, and I've got a countdown clock to try to get as many kills as possible to clear the level. Doesn't look like I'm going to reach my quota before time's up. I have a stabilizing button that'll stabilize the actual platform. And I can try to squish the guys by poking them. I've got the poke up pretty heavy right now, where you have to really give them a good poke to simulate the poke, just to make sure that there's a difference between the grab and hold. We'll let the level restart. And I'm going to grab that worm. It's kind of hard to see with my finger. Can't grab him. Alright, so if I grab him, and he'll stay basically indefinitely as long as I just lightly touch him, and that'll give me time to get my ball over there, or I run out of level. And the last big mechanic, I can double tap and get a roller in there. And I want to go to the next level. As you go to the next levels, you get multiple worms. And that's the game. Alright, we're going to take a look at this on another device. This is the NVIDIA Shield device. And we've got RollaMole here, so we'll go ahead and open it up. Now on this device, it doesn't support the pressure, nor does it support the haptic feedback. There's no vibration capability in it. Same thing, we'll go through the credits just more quickly. And you go in the game.
Are you ready to rumble?
And then I can do the tilting. That causes it to tilt and chase the worms. And here, since I don't have pressure, really just tapping the worms is all you need to do. So it keeps a semblance of a game even on a device that doesn't support all the technology we're looking for. And we'll take a look at another one, which will be the iPad Pro. And the reason why I want to bring this one out, and I'm just going to do the pen here outside the camera, is because it had an interesting side effect that it says it fully supports pressure, but in fact it doesn't. And the reason why it says that it does is for the Smart Pen. So I had to do some interesting coding that we'll look at in just a minute around how to compensate for a false positive on touch. But even on the iPad Pro, we've got our credits, our help, and then you can play the game. And the basic accelerometer and main mechanics that for this week are fully supported. So really just the piece that is the proof of concept for my capstone. The double touch works and the tilting works fine for this week's project. And you've got the stabilize and the exit. Interesting thing is where I'm doing some scaling magic on the UI to make the UI so it's not super tiny as you get onto big screens. And I've got another Android device, but it looks shockingly similar to the NVIDIA Shield. So that's me playing on multiple devices. I hope you enjoyed it. Now let's take a look at the code.
Hello, my name is Evan Schwartz, and we're going to be taking a look at RollaMole, which is the Week 1, Week 2 project for game development frameworks. I have two agendas on my Week 1, Week 2, which is to satisfy the Week 1, Week 2 requirements, in addition to putting together a proof of concept for my capstone project. So for the Week 1, Week 2 objectives, we have touch, multi-touch, accelerometer as part of the project. I additionally added pressurized touch and haptic feedback so that we could build out some proof of concept play code for a capstone idea that I'm working on. The game is built in Unity. I started out with the Cocos 2D framework. That didn't work out there. 3.17 had some bugs and problems that I was unable to resolve regarding their accelerometer, which is key to the mechanic of this game. So we switched over to Unity, and that worked out pretty well. The game is made up of 4 scenes. We have our home screen here, which is our main menu. We have our how-to scene, which is basically instructions. We have our credits scene, which basically describes where I got my stuff from and the fact that I made it. And then there's the game screen, which is the playing field. The game is intended to be played by 4+. Realistically a younger audience, keeping colors very much primary basic colors scheme and interface very, very simple. If you did not get a chance to get a close-up on the screens during the video of me actually playing the devices, don't worry, I have a screen capture right off of one of the devices that I'll play at the end of this video. So if you just want to go and get a close look up of how the screens work and everything interacts, you can skip to the end if you're not interested in reviewing the code. The pieces on that video is if you see the worms squishing, since you can't see my finger, that's them most likely getting poked by my finger. Alright, so we'll take a look at the scripts. So we only have a handful of scripts that control the entire game, so there's not a lot of code logic that puts it all together. So there are some interesting pieces. The floor management manages the accelerometer, so that's an important piece. The game script is all of the back-end game logic, other than just the game mechanics, countdown, score, that sort of thing. Not super interesting there. Keep Alive is a utility script. Menu manager manages all the clicks. The move balls with keys, that's syntactical sugar for me. It was just easier for me to move the ball around while in the Unity editor to test out some of the other game mechanics that weren't key to specific functionality of mobile. So that just allowed me to move the ball around. I threw that in there. Camera shake, that was just a cool shake effect that I wanted to add as the ball hits the sides to, add some additional immersion. The wall scripts essentially detect the ball or the roller pin colliding with them and causes the camera to shake. And the worm behavior has a lot of the haptic feedback routines, the buzzing sounds if you squish. It has the pressure sensitive touching on it, as well as the ability to just touch and grab. The game script has the 2-finger touch where it instantiates a roll. So we'll just go down these one at a time and review each one of the pieces of code. So this one, destroy in seconds, this is just a helper script. For instance, when you squish the worms and they turn into a squish piece, that's an instantiated object. I just threw this script on each one of those prefabs. It creates it, and then it cleans itself up in X amount of seconds. So however long I want that squish to sit there. In that particular item, the squished item, I put a particle effect on there where it looks like little pink gushy things squishing out. So just wanted to be able to create it, set it there, and then let it clean up itself. So this script made that really easy. It just says destroy the game object in whatever amount of time you have set for the public for the script. The floor movement's a little bit more interesting. That's fine. We're going to keep our game states here. So am I starting the game? Have I lost a level? Have I won a level? These are all of our main public and private members that we're going to be using to keep up with various mechanics, such as how long do I want this, the game's about to start type of thing to sit out there as it's playing the audio. And then when that goes away, what's the countdown to where the level actually begins? All of that's just to build anticipation for the players that are getting into the level and give them an opportunity to recover from having lost or won a previous level. On startup, we're setting the screen orientation to landscape right. That was a function of my development environment. Computers here, all the cables are coming off to my left. All my devices are kind of stacked there through a USB hub. And as I'm pulling them and playing them, the cords are going off to the left. It was just easier to set my landscape in that direction from a development and testing standpoint. Probably should use it to do there that I could flip it either one of those directions but still maintain landscape. But in my case, it was just easier to force that particular direction. This is a helper function, get state, text. All this is doing is you'll see as you're playing the game, you get the little notifications, get ready, it's a new game, you lost, let's replay the level, you won, let's go to the next level. And then it plays sounds of cheering people or a little kid depressed because he lost type of thing. So that manages all of those mechanics in the game. Reset the level. This is a public method that's accessible from a lot of the other scripts, so that way we can manage from the game script whether you won, lost, or not, and then pass into the floor to reset the floor, stabilize it, reset up all the timers, put up all your labels, and prepare the player to either replay that level or go into the next level. This was a requirement of the package that I'm using, the Nice Vibrations. On iOS, you have to sort of initialize haptics for your application and then release it on exit. Android doesn't require that. And then you go into the update, and essentially all we're doing here is we're running down some timers, and once the timer's 0, we can go in and start playing the game. This is for managing whether or not I want the output to be visible or not visible, and it outputs the message that I want it to be displayed. And if we're in a moving state, I don't want them, what I'm controlling here is I don't want the player to be able to squish or interact with the worms while we're in the countdown waiting for the level to start. So I'm just making sure that, hey, am I in a moving state? If so, then all the other mechanics can test against that before doing anything. Otherwise, make it move 10 meters per second per frame. This is essentially a direction. I think I've hence made that a property that you can set for the speed that allows the tilt to go wherever you want it to go. I'm adding a clamp to that tilt for the transform location rotation. And that's all coming off of, let me grab this thing. That's all grabbing off of this accelerator. So we're pulling the acceleration directly from the input, which Unity exposes, and essentially I'm rotating on 2 axes. I don't want to rotate in the Z, so I'm controlling the Y and the X, but from a direction standpoint, as far as rotating the platform, they translate differently from the accelerator's axes to my platform's axes. So I'm basically transposing my Y to my X and my X to my Z because I've rotated the device and I'm playing in landscape. I'm normalizing my magnitude and clamping it, and that's where the clamp is happening down here. And this is just managing the speed at which that it's going to it's going to actually tilt. How quickly am I going to take that acceleration and ramp it up? And I think I put it at 40. That's just a bad comment. I'll have to go back in and fix. This is some older debug code. Otherwise, if I'm not in a moving state, if I'm not ready to tilt and do things, then my state timer can count down, and this just manages all my levels as to whether or not I'm saying, hey, the level is starting in a certain amount of time, or whether or not I want to disable the level and put the game state activity there, and that's what this calls, is I put it to the get game state, such as prepare for the next level, and it makes the you won, you lost, and let's get ready to rumble, I believe is the sound effect. On the game script itself, this is where really all the mechanics, so I grab all of my text objects from the Canvas UI so that I can keep up with what your level, your score, your ranking, and all that stuff is. If you play it, you'll notice that when you double tap and it brings in the roller, a bunch of trumpets play, and the roller goes through, and then after a second the roller goes away, the trumpet kind of peters out, and the ball returns. So that manages those two things. This has given me a reference to my ball and my roller. I'm just managing activity to make, basically visibility, to make them appear and disappear. This is me getting access to my arena parent and my worm prefab, and mostly just so I can get components off my arena parent if I need to, other than it being this particular object. This is my stabilize option. So essentially the button that's on the main game that stabilizes, that sets the field back to a stable point, essentially back to origin, and resets the ball. If you're savvy, you may notice that you can use stabilize to cheat a little bit and move your ball closer to where a worm is. So I had an opportunity to put the game in the hands of a little boy, and he loved it. He just giggled and had a good time with it. And the haptic, he pulled his hand away from the biting haptic, which is the chomp and the haptic feedback, the buzz, and the whole thing, right? So really the effect I was looking for was less about just the buzz and more about a conglomeration of all of those effects pulled together, making that one effect. So anyway, that he never really figured out that you could use this to get as an advantage mechanic in the game. This is just some helper methods to change the worm count and update the score, accessors for lack of a better term. This starts the level, so here's a helper function that kind of preps everything, gets my floor, resets the floor. So this is that public method that was resetting the level. I'm making sure that I stabilize everything. And then this becomes my level mechanic. So outside this start level, it's determining whether or not I won the level and I've incremented it, or I lost the level and I'm replaying it. So this routine doesn't really know or care about that state that's being passed in through here. I just need to know, did you win, did you lose, blah, blah, blah. If you lost, I'm not going to reset your roller. You'll have to get through it. If you win, you get another roller. I played around with maybe giving you multiple rollers, but it became too easy with the roller to wipe out the level. So ultimately, just through some lightweight testing, you ended up with one roller. And then this is the level timer. I basically increase your timer based on your worm target. That's how many kills you have to get. And then your kills are right now is a working number of 5 times level. So that's just a quick and dirty mechanic to have a progression of levels. And it seems to hold pretty well. It gets a little bit challenging, but it's not too challenging. And it's really just fun to get it up to, like, I've gotten it to level 10 where it's just 10 worms in there and you're squishing them all. So that's pretty exciting. I think Dougie, the little boy, he got it up to level 6, and when he got the roll and he squished them all, he just thought that was the best thing ever. Game started. This is just a boolean. This is just checking whether or not on the floor is moving. So again, this is me being able to use and constrain other mechanics while the board is in the let's get ready to rumble. Game's about to start in 3 seconds. I don't want any of the other action items or inputs for the user to take action until the game is started. At this point, I'm using my start level to kickstart level 1, and I'm telling them the game is starting, and then I'm just grabbing a reference to the audio source, and then the bulk of it happens up here in the update. So this is my heartbeat. What I'm doing here is I don't want to take actions on the worms more than about once a second. right? So make a decision about once a second. That's a pretty good heartbeat. And if I'm above a second, then let's go and look and say, hey, did you kill a worm? Do you need another worm? Because at each level, I want you to have that many worms available. So level 1, you need to always have a worm. So if you kill a worm, there's a good 1 second heartbeat, and then it'll bring back another worm. If you're at level 2, there's 2 worms, but if you kill one, there's a heartbeat and one's coming up. And then it starts to get a really organic looking, these worms are attacking, right? 2 at a time, 3 at a time, and so on. But they don't all come up at the same time and go down at the same time. It looks more organic, and they randomly move around. This tests to see if the roller is currently active. If not, you can touch a 2, make sure that you have rollers. Again, right now this mainly, I'm only giving you 1, but this code is set up to that if I could give you more than 1, it'll just decrement the count of rollers. So that just gets into if I wanted to take this game to fruition and put a little bit more testing and design time in it, it gives me the possibility of having maybe a way to collect an extra roller. Maybe there's a special worm that pops up, and if you get him, you get an extra roller. That might be an interesting little add-on to it. But all of this is just really wire up for moving the roller into place, making sure that it's positioned where I want it in the far right side, it's rotated properly, and then I'm going to activate it, and then gravity will take over, it'll drop, and then you can tilt and just roll. It only lasts about a second. That's the roller timer down here, and then at which point it puts the ball back, it takes the roller away, and then it plays the trumpet sound that kind of peters out, which is kind of funny. If the game is started, this is the level timer, game over. This is basically testing to make sure that you can get all of your killed worms in the given time associated with the level. So this is the antagonist on the level. Otherwise, you could just roll around and kill them as long as you want. So this makes sure that there's a certain amount of stress, right, in the game that I need to get these worms before that clock counts down. And this is just updating. This might be a good idea to put this in the 1 second click, but it didn't seem to hurt anything just to throw it here, and I'm just updating the HUD UI. There's plenty of room for improvement all over the place in this game, but mainly the core mechanics that we were searching to experiment with worked really well here. Keep alive. This is another little helper script. Not much going on here. Essentially, I'm making a static instance of anything I throw this on just to make sure it doesn't create itself, because once I do this, this object stays alive through loading of scenes. So it's a perpetual sort of a global object. So that manages that. And then this is just to, if it has an audio source, the expectation is that, it'll play right when it's created, instantiated on start. So this is another little helper that it says, hey, if you have an audio source, let's go ahead and play it, and then we're going to keep you going. So this really worked out for my background music. I just create an empty object, put it on there, and it spawns at the beginning of the game. So not a lot going on in this script. Menu manager, same thing. This is really just maintaining a class for my menu object. So this is, and right now all my menus primarily do is load scenes. So not a lot of extraneous activities there. So it just loads the scene. This is my other syntactical trigger one. This is just me grabbing the arrow input and moving the ball a certain amount as I click on the key down. Again, this was primarily, I put this together just so I could test real easy inside the Unity editor. Not key to the game. You can't even play it on mobile. The shake camera. This I pulled this code from this place here, so IP devs, and there's the URL. I had to make a lot of changes to it. It wasn't really good out of the box, but still the bulk of the mechanics was his. There were some interesting things I had to do to compensate between Android and iPhone for this to appropriately work. My iPad itself, by looking at the device, for some reason things weren't scaling properly on my iPad Pros. They were on my phone and on my Android devices. Everything seemed to scale very consistently on everything except for my iPads. So I just put a little bit of code in there that backs off the gaming field a little bit by a factor of 3 units. Just push that one, the whole play field that you can tilt, just push it back about 3 units, and that kept the iPad Pro in check. So that was the main piece that I had to do here. And then this is the shaking mechanic, which essentially is what's my shake speed, time my delta time, position, and then it's using inside unit sphere as a randomization to move the camera within a spherical, all 3 dimensions, right? Moving it towards within whatever that amount of time is. So the big thing that I had to change here is that there was nothing it would move it, and then it would just stay at the end of wherever the move was. So I just wanted to make sure that by the time it was done shaking, whatever the time to shake was, that we could reset the position back to its original position, which is the whole point of grabbing this original position on start. So then I can just throw that onto the camera, and then I've got a public function that you can call from another script, which is what the wall scripts does, and you'll see that in a minute. And it essentially says shake it, and it just time to shake is whatever you set. All right, looks like we may have lost audio there for a second. All right, I'm back. So just to recap, in case I lost that, I'll try to fix it in editing, is that whatever you set as your shake time, that becomes the time to shake, and as long as it is shaking and you have time to shake is greater than this, controlling with a Boolean gate and transforms its position to set it back. But essentially all this does is just cause the camera to shake whenever you call that method. The wall script has an audio source and reaches out to the camera. So if the camera is not specifically assigned, it'll assume it's the main camera. It grabs an audio source. And on collision enter, so anytime anything tagged as a ball, so both the roller and the ball have that tag, it grabs that camera and then calls, which is the shake camera code component we just looked at, and calls shake. And then it plays the sound as it shakes. Worm behaviors, the next more interesting piece. So in here we've got our Squish Worm, so this is another prefab, so that way when the worm dies we can instantiate that. That uses a conglomerate of the other scripts on it, such as the destroy in seconds, so it can clean itself up. It needs access to the floor movement just to make sure that it can manage points and score. It controls a public pop speed. How long does it take to get from below the floor up the floor? So it's about a half a second rise. How long do you want it to stay? 3 seconds. And then when you go back down, how long fast it is, and then pop speed controls that. So it's half a second up, 3 seconds, half a second down. Grabs the game script reference so that you can access it as well for, again, managing score and things of that nature. Is touched, that's just a single touch mechanic of the game. So as long as you're not pressing too hard and it doesn't detect it as a pressure touch, you can touch it, and as long as it's being touched, it'll hold it there, right? And lets me know whether this one bit you or not, so it can keep its head red. And this is the worm head object itself, so that's what I'm really testing to see whether or not it's been touched, right? So I grab the worm head, game object, red head, and I need that so I can turn it red. And then of course it has its own audio source. So once again, here in the is touch supported, this is where things got a little bit dicey, and I touched on that in the video recording me playing the devices. For some reason, well, not for some reason, the iPad Pro has a stylus, a smart pen that you can use. So the iPad reports, or at least the iPad Pro reports back that it supports pressure touch, when in fact the screen does not support pressure touch, but the pen does. And I don't own a smart pen, so it was reporting to me that touch was there, and it was messing up my gateway mechanic to say that if you don't support touch, then go ahead and let the regular touch squish them, so that way you can still play the game, so it doesn't look like a broken game. So what I've done here is I'm saying, look, I'm going to return true if input touch pressure supported returns true, right? Because that's built into the Unity framework to tell me that it supports it. But if it's an iPhone and it's an iPad, by testing the device, I'm going to return false. I'm just going to say, look, it's too wishy-washy on the iPads. I can't get a declarative answer from you, so I'm just going to assume it's false, and we're going to go the other way. Otherwise, we're going to return touch pressure supported if touch pressure supported supports it is true. If it's on an Android or a phone, if I go to a Windows phone and it supports it, I don't think we have this problem. So this is just compiler directives so that I compile certain pieces of code, because this namespace doesn't exist when pushing to an Android, which is primarily why that's important. So I turned all of my touch pieces into on mouse down events for two reasons. One, it made it easier for me to test while I was in Unity because I could use my mouse, and two, it just made it a little bit cleaner from a code perspective. So essentially what this is telling me is touch true, is touch false. It's doing a ray cast. So as I touch the screen, it's casting a ray from the point of that touch into the 3D space, and any objects that are passing through, it's going to fire and say, hey, I've touched that. Well, in this case, this is the only object I'm really testing for, is the worm, to see if you've touched the worm. And at that point, that gives me whether or not the worm is being touched. Destroy worm. This is if the game is not null, did bite, the game updates score. So this is just a method that's saying, hey, if the worm's destroyed by any means, whether it's destroyed by the roller, it's destroyed by the ball, it's destroyed because you squished it, did it bite you? Let's go ahead and give you, using the game component that we got in the start, let's give you 5 points, or we'll give you 1 point, and then we'll decrement the worm count. And that's primarily to get the game script the ability to increment another worm, to give you another worm. Because again, that whole organic or dynamic operation, to be able to create worms based on your level and keep them coming. If it has a Squish Worm prefab, it'll go ahead and instantiate it. So that's essentially finding out where the current worm is, instantiate this worm, and set its local position so that when you squish it, it looks like you've actually squished the worm. So that's a pretty good effect. Game object. Here I'm just hiding the original worm, and then I'm going to set its destroy time to 1.5 seconds. And the reason being is because I'm instantiating another worm. I'm trying to play some music in the background, and I don't want it to just pop out of existence and all of my sound and audio sources. So about 1.5 seconds. So technically the worms are there for 1.5 seconds, playing out their sound, playing out their closing scripts and all that stuff, and then they eventually clean themselves up. This is the detect touch, and I pulled this from Stack Overflow here. And essentially this is the ray casting thing we talked about, and it issues an on mouse down if there's a hit detected for this particular object. So this is the salient piece of that. It goes through each one of the touches, it grabs each one of the touch phase and equal to begin, and does its construct, ray, camera, main screen, and this is just shooting a ray from the point at the screen. So it is built into the camera functionality, and it's shooting a ray out and trying to get a touch against a particular position in the ray, and then seeing if it hit. And if it did hit, we're good. Worm bite. This is me determining whether or not the worm's going to bite. So I'm going to say true. I'm going to play the audio source for the worm, and this is where I'm going to change the worm's head color to red, and then I do my failure haptic vibration. And this is where I started getting kind of unhappy with this guy's implementation of this. And you'll see that I've added the Unity handheld vibrate that comes with Unity. To me, this is actually a better vibrate for the bite than the one I got with the package. So ultimately, if we move forward with the capstone, I'm just going to end up writing my own interface to the haptic feedback. Just didn't have enough time on the clock this week to do that. Worm squish, his heavy impact, which is really just a bump, feels like a button push, gives me that little nice squish. So this one was a lot closer. I was happier with this one. And then it caused the destroy worm. And again, there's a lot of tail on that, so it really just hides the worm and then waits about 1.5 seconds and then destroys it. This is the update, so if the floor is moving, once again, if we were talking about before, this makes sure that the game is actually going on. I don't want the worms doing anything until the level starts. So you'll see that their little heads pop up, and you can see their eyes and they're wiggling. And they're just staying there waiting for the 3-second countdown. I thought about cleaning that up, but as I was playing with it, it actually gave me an opportunity in the 3 seconds to get my device tilted in a way to where I could start moving in that direction. So I kind of left it in there. It may look unintentional, but in the end of the day, it actually became a valuable mechanic for me to testing as I'm playing hours and hours and hours. This trying to kill these worms starts to become more and more challenging. This is me doing the detect touch, so this is just the raycast. Hey, am I touching the object? Am I touching the object? Am I touching the object? I'm getting my original local X, Y, and Z. And if the worm has not grown through the floor, I want to grow him up. And touching the worm holds it in place. So I'm going to check, is it touch? I'm only going to count down the time. So what this little piece here is doing is it's checking to see if the worm's below the floor. If it's below the floor, I'm not going to count against its stay time because it hasn't grown all the way up yet. And if it does grow all the way up, and then I'm going to start counting against its stay time. It only wants to stay there for 3 seconds. But if you're touching it, I don't want to count that 3 seconds. I just want to skip over it. So if you count down 1 second, it's like a stop timer. You can stop by putting your finger on his head. If the worm, got a little typo there. If the worm has grown up from the floor and stayed more than stay time, then shrink it back down. So this is the other half of that. It stayed there. You didn't squish it. You didn't grab it or touch it or push it or do anything. So then it just starts to wiggle its way back down. And at the end of it, if it has actually completed going all the way down, let's go ahead and destroy it and then send a worm count. You didn't get any points. You get any score. This worm just came up and went down, right? Now we get into the sort of the proof of concept here, where I'm testing on pressure. Is it supported, right? So the first thing I'm going to do is I'm going to test this little check to make sure that I can even run through this exercise. So is it supported? And that's using my Android and my iPhone code up above, because the iPad's a little bit different. And is it a biter, right? I don't allow you to squish a worm that's bitten you. And I make sure that the input count is exactly 1 because I have a 2. I don't want you pushing your hands all over the place. You can only squish 1 at a time. And if it is touched and the pressure is greater than 3, right? And that's me going a little bit over the top. You could probably do a 2, but I wanted to make sure that there was a big difference between touching it and holding it and pushing it. At 2, maybe just because I got big fat fingers, on occasion when I was trying to hold it, it was detecting it as a squish, which wasn't my intention. So I bumped it to a 3. This is something, if a game like this goes further down the road to fruition, we'd have to dial in a sweet spot for that. Then this is just a randomer, 50%, so either you're squishing it or it's going to bite you. From experience, I'm telling you right now, I don't know what this random range does, but it feels like it bites me more than it squishes. If I don't support the squish mechanic and it didn't bite me, then I'm just going to allow a touch to do the squish and the bite down here. So I still want to keep the fact that I can touch and hit and squish, but the problem you have with this is you lose the ability to hold the worm. So if the device does not support pressurized touch, one of the mechanics of the game kind of evaporates. When you touch the worm, it's either squishing them or they're biting you. And then this is the on trigger, and if the ball, which is essentially an object with a tag ball, right? So the roller's a ball and the ball's a ball. It squishes the worm and then goes through the entire worm squish mechanic. That's it. That's the entire script in a nutshell, and they're essentially applied to the various aspects of objects, so as you put them here. From a learning experience, I got to tell you, even though I felt like the Cocos 2D was a failure, I spent a week beating that thing to death, and the reality was the comparison between it and Unity was phenomenal. The wire up, the setup, the complications around getting it to work. Oh, it was a headache. But when you get into it, I mean, the pieces generally do work. It was able to publish to both my platforms. I had it working on an iPhone. But then when you get down to the nitty gritty, where the native cost accelerometers weren't working, or some of the other mechanics I needed weren't working, that was fairly disappointing. So I was kind of interested to see what we could have done with that. And I may take a second stab at it if I can take the time to fix some of the key mechanics I'm going to be using next week. Although next week I'm really interested in looking at Unreal 4. I've never used it before, and I hear it's pretty good. From a development strategy, I'm continuously impressed with the level of capability that these frameworks deliver. componentized development. I come from a professional background, software development background. We're built business applications, right? Standard Visual Studios or Java Studios, where you're Eclipse, where you're building out all the code and trying to structure all your files, and you're just referencing your code. But being able to just take a discrete piece of code and drag it onto an object as a component and build basically inheritance first versus being able to have conglomerations of behaviors. Um, I really like the component-based model. So the strengths of reusable code, which has always been the holy grail of object-oriented design, right, is the fact that you could build something and inherit it from it in its reusable code. I really think the component style delivers on that promise in a much better way than object-oriented design. Or maybe as a collaboration, they work together to really make it work well, but from just a visual layout and being able to put it together, once you've got your head wrapped around component design, you can put it together. I mean, I burnt the first week of my 2 weeks on Cocos. So with the Unity's environment, its layout, and its well-organized way of putting things together, the game that you're seeing was largely put together in about a week and a half. About Friday, I called it. So I had, Friday was sort of a get over it day, and then Saturday and Sunday, and then the rest of this week up to Saturday. And this is, by all intents and purposes, a complete game. You can play it, you can win, you can lose, and you can get score, and it has all the interesting mechanics, and it's got some strategies you can play with it. So for 5 days of not putting a whole lot of thought into it and centering as your key focal point a couple of mechanics, right? Here being the accelerometer and multi-touch were the two big ones, and then I was trying to get my capstone stuff in there just from an optimization standpoint. We were able to build a game around that could go into any device or any platform. So overall, very impressed with what Unity can do. So following this is going to be an entire it's like a 2 minute of me playing right from the iPhone, and that'll give you a good look at it. Thank you.
Are you ready to rumble?